Suppose you have a plano concave lens with the index of refraction n equals 1.50. I'm going to call glass. Placed on a flat glass plate as I showed in this picture here. Its curved surface has a radius of curvature, I'm going to call it capital letter R, equals 8 meters, and is on the bottom of the lens. So the lens is illuminated from the above with the yellow sodium light that has a wavelength of 589 nanometers. And the series of concentric bright and dark fringes are observed due to the reflection. So the interference pattern has a pretty much dark spots in the central part of the lens, right? And that dark spot at the center is surrounded, so suppose that this is the dark spot and it is surrounded of 50 dark rings. So this is an exaggerated picture, so that's a 50 dark rings, and that is the center of the curvature right here. And we also know that the outer edge right here will also have dark fringes. I should use the black, so dark fringe, and then most probably we would have dark fringes, but we're interested in the central area. So if I had to draw, this would be the center, and then I would have rings going around all the way to the edges. Now we want to find out what is the thickness at the center of the pattern, which is on my graph. This would be what we're looking for, this thickness. Part B, we want to find part A, part B, we want to find out what is the radius of outermost dark ring. So R for outermost dark ring is a question mark. And finally, we want to find out what is the focal length of this lens. To better analyze the situation, let's draw a more useful picture here, where we have two interfaces where the reflection happens. We have glass from the lens, glass air interface, and then air glass interface. When the light is incident to one of the glass air interface, it's going to partially reflect and get to here, and then it will just refract through the air, okay, and then reflect from air glass interface, the bottom interface. Okay, so there are 2 points, point A and point B, where we have reflection happens. So let's see what happens to the phase of a reflected ray. So at point A, we have the ray goes from glass to air, which means no phase change. No phase shift, that means, why is it? Because index of refraction of glass is larger than index of refraction of air. So when a ray is moving from higher index of refraction to a lower index of refraction, there is no phase change. While at point B, we have the light ray going from air to glass, and index of refraction of air is less than index of refraction of glass, which means the light goes from lower index of refraction to higher index of refraction. Then we observe a phase shift of 180 degrees, or half a cycle. Okay, now we can write the condition for distractive interference. So we know the condition for distractive interference is the path length difference should equal m plus 1/2 lambda, and we know that the second ray, let's call it second reflected ray, and a first reflected ray. Second reflected ray has gone through one thickness and two thicknesses extra path, so two thickness, plus let's consider the phase shift 1/2 lambda, that equals m plus 1/2 lambda. So from here we can find that 2t equals m lambda. So, and then to find the thickness, that equals m lambda over 2. And we can just plug in the numbers. Since we know at the center we have m equals 50 rings, so 50 dark rings, and then lambda, we had 589 times 10 to the negative 9 meters divided by 2 gives us 1.47 times 10 to the negative 5 meters. This would be the answer for our first part of the problem. Now let's see, we're gonna find what is the radius of outermost dark ring. So we said that the outermost dark ring will be on the exactly on the edge. Let's draw the diagram again. So we have the air between the plano concave lens. This is the lens, and we have here we have the actual lens flat. So let's not draw that. So we know that right here on the edge we will have a dark fringe, and so let's build what we want to know, what is the radius of that. So if I draw them from the center, I draw a line to the center of the curvature. This whole thing, let me use a different color. This from edge to the center of the curvature will give me the radius of the curvature. So from here to the center of the curvature is also an R, while we have from this point, the pink point, to the edge is the radius of our dark fringe. So if we take a look at, let's name these points P and then O and C. So if you look at the triangle POC, we can say the PC equals, if we know that the thickness of the air in the center is T, then PC would equal R minus T. So this other side of the triangle is big R minus T. Then Pythagorean theorem will give us R squared equals R minus T squared plus r squared. Okay, let's do a little math here. So r squared equals r squared minus 2rt plus t squared plus r squared. And remember, we're trying to find this little r here. Big r's will cancel out. Little r squared equals 2 big rt minus t squared. And then little r would equal square root of 2rt minus t squared. All we need to do, plug in the numbers. Square root of, so for the r, we have, it was given to us, it's 8 meters. So I'm going to plug in that back in here. So I have 2 times 8.00 meters times t. We found it's 1.47 times 10 to the negative 5. Let's just plug that in. 1.47 times 10 to the negative 5 meters minus 1.47 times 10 to the negative 5 meters squared. So this last term is really, really small, close to 0. So we can neglect it. And then I can say that r equals square root of 2 times 8 meters times 1.47 times 10 to the negative 5 meters. And that will give us 1.53 times 10 to the negative 2 meters, which is 1.53 centimeters. Okay. Now we want to find out the focal length in part C of the plano concave lens. So plano concave means one radius is infinity, that's the plane part, and a concave one should be positive 8 centimeters because it's a concave lens. Then I can use lens maker's equation, 1 over f equals n minus 1, 1 over r1 minus 1 over r2. That equals 1.50 minus 1 times 1 over infinity minus 1 over 8. This is meters and not centimeters, so I made a mistake. This equals punching into calculator. Actually, let's just punch in with the reciprocals. F equals negative 1.6. That's not correct, so it equals negative 16.0 meters. That's the answer for the part C. Thanks for watching. Stay tuned for more.